Hello guys, welcome to Pfizer Workshop, and in today's video we're going to be checking out how to perform an experiment that is based on a PN junction diode that is in forward bias, and we are going to obtain the characteristics of this diode using the software, that's the OrCAD software. So first of all, if you're starting from scratch, so this video is made for you, and if you're just like you've just like installed the software on your computer and you have done nothing on the software, so I'm just going to show you step by step how to perform this experiment properly on OrCAD. I've already performed this experiment on TinkerCAD, so you can just click on the pop-up I button, so you can just like watch my video on that one. So let's just get started. First of all, we're going to open the software. So over here I'm going to be using the OrCAD PCB Designer Professional PSpice. We're going to hit OK. It's going to take a while to load up, and we'll be greeted with a startup page. So over here you can see you're just getting a start page over here. So what you gotta do is, first of all, let's just wait for it to load up. So what you're gonna do is you're just gonna go to files and then new, then project, and then you're just gonna click on analog or mixed 80 and just name the project like anything. So I'm just gonna name it as diode trial underscore trial. And over here you have to just like mark the location on which like where your project is gonna be saved. So I'm just gonna like, I've just already created this particular folder, so over here all my projects are gonna be saved. So I can of course like change the directory or go to any other drive or something. So of course you'll be able to figure it out. You just like create a folder probably in your desktop or somewhere else. So let's just hit OK, and then it's just gonna ask us if you want to just like create based upon an existing project, but we want to create a blank project. So click on the blank project and click on OK. So it's just going to take a while, and another tab will open right here. I hope you can see my cursor. So you can just like cross the start page, so just right click on the start page and just like click on cross. So over here now we have a fresh page on which like we can just start the designing. Now if you're starting up with TinkerCAD, like if you just install TinkerCAD, so first of all what you gotta do is you have to like install all the parts library into your TinkerCAD. So you have to import all the libraries etc for the parts. So right now none of the parts are gonna be available in TinkerCAD if you have just started it out. So what you're gonna do is you have to just like click on places and then click on parts. Over here you can see a window has just popped up. So what you gotta do is to import new parts, you're just gonna click on here, and then you're just gonna go to libraries over here in the directory, the library directory, and just like copy down all these parts except for the folders. Now you're not gonna copy down the folder, and you're just like you're gonna click on open, and then you're gonna do a similar thing, like again go to parts, go to library, and then just click on PSpice and import all the parts from there, like over here. So we're just gonna import all the parts from here as well. So you're just gonna click on open. So I've already done this step already, so I'm not just gonna do it again. But if you're just starting out with TinkerCAD, so you need to perform this step. So let's just get started. First of all, what we need is a diode. So for the diode I'm going to be using a 1N4007 diode. So this is a general purpose diode. So it's just like the most common type of diode that you can just find everywhere. So of course the data sheet for the diode, I guess I've just opened it up. So over here you can see this is the data sheet of the diode, and over here you can see the maximum current that is rated for is 1 ampere. So this is all what we want to know. By the way, we all obviously don't need to know this thing, so I just wanted you to show the data sheet of the diode, and I'll just link this data sheet in the description of the video if you want to check it out. So anyways, so skipping with the data sheet, let's just import this diode. So what I'm going to type in to add the diode is D1N capital N 4007. So this is the diode part number. Over here you can see it's just showing me a diode. So there are many multiple diodes like D1N4004 diode and D1N407 diode. So we're just gonna double click on this diode, and now the diode has been attached to our cursor. Now we're just gonna click it right here, and then you can see it's still attached to our cursor. Now you're just gonna press the escape key, Okay, so this is how you're just gonna get rid of the part, so you just like don't end up like dragging that part all along. So, and now if you want to like zoom into this thing, so what you gotta do is just press Control and use your scroll wheel to just zoom in. And if you want to navigate, just click your scroll wheel button, just like you can just navigate it around here and there. So right now I'm gonna change the orientation of the diode. So again, you're just gonna right click on this thing on the diode. So I'll click on the diode and then right click, so rotate, and then we are gonna mirror this diode so that it's just like we're just gonna follow a particular schematic for this thing. So okay, now the diode is in the correct orientation. Now we're gonna import the power supply, so that's gonna be the VDC. So you're gonna type in VDC, that's the DC voltage source. So over here you can see you've got the voltage source, so I'm just gonna set it right up here and just now press escape to get rid of that. And then we are going to import a resistor, so R we are going to type in, and you're going to make sure that you pick up the analog resistor. Double click on this. Now you have the resistor with you, just place it over here, press the escape key to get rid of that. Now we're going to hook up everything. Okay, so we're gonna use the wires. Over here you can see this panel right here. Over here all the wires etc are located, even your ground is also located over here. So I'm just gonna cover that all. First of all, what we're gonna do is we're gonna place our wire. Now click on this terminal right here. The wire will be just like extend from that terminal, and you're just gonna click on this terminal now. So you can give one bend on the wire without clicking anywhere, so don't click anywhere if you just want a 90-degree bend in the wire, a single 90-degree bend in the wire. So I'm just now gonna click on here. So again, now we're just gonna connect this diode to this power supply. And now to give it one more turn, now what we're gonna do is like click it over here and then here. It's pretty much similar to what we used to do in TinkerCAD, but like it's a bit more intuitive. So now let us just set up the voltage for our power supply. Okay, so now what you're gonna do is now click on this and right click on this and just like click on edit properties. Over here you can see you can just change the value of the power supply. So we're gonna take a 100-volt power supply, so we're just gonna click like select 100 volts. Just type in 100 volts over here. Just gonna change the orientation, the distance of this a bit, because of course we want the project to look nice. We're also going to change the value of the resistor. Again, click on this. Do not click on the resistor itself, otherwise it's just going to change the resistor. Click on the value of the resistor and then click on edit properties. So now what we're going to do is set it to 100 ohms, and diode is just fine. Okay, so of course we don't want to change the properties of the diode. So now we're gonna import a ground. So over here you can see what I've done is over here on this panel you can see over here there's a symbol. Now you're just gonna click on this, and what we're gonna do is just gonna click on this ground CAPSM. So this is the most commonly used ground symbol in electronics, so we're gonna use this symbol, and this will show where the reference is in a circuit from which all the voltages will be measured. So we're just gonna click on OK, because see you can also use the differential voltage measurement function, but that's a bit complex, so we're just gonna stick to this ground reference voltage measurement for now. So just gonna click on OK and just like place the ground over here. Again, press the escape key. Then we're gonna go on ground again. Then we are gonna search for VCC, that's the voltage at common collector, VCC. Okay, so we're gonna click on VCC CAPSM. So that's the common symbol that we use for VCC. So this is gonna be our reference. So over here, like we are just gonna like mark this point as VCC, so that we can, when we simulate the circuit, we are just gonna like check the voltage at this particular point. So we're just gonna click on OK. Now we're gonna click over here. So this is our VCC. Again, press escape to exit this thing. Now we're just gonna change the name of this thing, because again you have to just click on VCC, right click, then edit properties. So over here we're just gonna change the name to VD, because it just makes sense, voltage across the diode. So somewhat, I hope you're there with me. So now our circuit has been fully assembled, but now to simulate this circuit, first of all you're gonna create a simulation profile. So on the top left hand corner of your screen, you're going to see the option of PSpice. So you're going to click on this and create a new simulation profile. You're just going to name the profile. I'm just going to name the profile as diode sim, something like that. Okay, and just click on create. Now you can see a window has just popped up. Over here you have to you can just edit the settings for the simulation, but we're just going to cross it for now because I'm just going to show you how to bring up this window on your own if you just miss it or something like that. So we're going to click on PSpice and edit simulation profile is where we're going to go. In this you have multiple options on which analysis you want to perform on your circuit. So we are going to perform a DC sweep. So a DC sweep is basically the voltage source is going to increase its value as per the parameters that we set over here. So we want the DC sweep to be linear. We don't want a logarithmic sweep or something like that. So we're just going to keep it linear. And first of all, we're going to name the voltage source that is going to sweep its voltage. So it's V1. And then starting value will be from 0 volts. We'll start from 0 volts and we'll go all the way up to 100 volts. And we'll go in an increment of 1 volt. So this is what it is for. So it's just going to increase the voltage by 1 volt till it reaches from 0 to 100 volts. So this is how the data will be collected in a circuit. So first of all, it's just going to measure at 0 volts, then at 1 volt, then 10, then 2 volts, 3 volts, and so on up to 100 volts. So it's just going to take up 100 or 101 readings in a circuit. Then you're just going to click on apply and OK. So guys, I'm just really sorry to inform you that I just made an error in the circuit. So that was in the ground, so we don't have to use this ground. So we're going to go into grounds again. Then we're gonna type in ground GND and we're gonna use this 0 CAPSYM. So this is what we are gonna be using. So this will just mark this node as 0 volts. So this will be our reference node that's set to 0 volts. So now our simulation will just run fine because I was getting some errors in the simulation. So that is why I had to change this later on. So I'm really sorry for the hiccup, and let's just simulate the circuit again. So I'm just going to run the simulation. So again, if you just want to see the properties, so the properties are all the same. So I have not changed the properties of the simulation. Now we're going to call it PSpice and just run the simulation. Now here you can see a new window has just popped up, and over here a beautiful simulation results that will be not present at first. So we are just going to get the characteristics graph of a diode now. So what we're gonna do is just go to plot and then axis settings. On the x-axis you're just gonna add a variable. So in the variable section, what you're gonna do is just disable all of these things: power, alias name, and current. So what we want is the VD. So that's the voltage across the diode. So I'm just gonna show you. So this is the voltage that we're talking about, VD. So it's a voltage at VD. So this is the reference. So we're gonna just click on this, and over here you can see the trace expression has just changed to VD. Be careful, you don't have to click each and every option, otherwise it's just gonna add multiple options in the x-axis. So just gonna delete that. Now we only want the VD in this thing, so just be careful of that because we had some issues with that. So we're gonna click on OK now. And OK, so you can see the scale has just changed. Now our scale is from 0 volts to 1 volt. Now we're gonna add a trace. So just go on add trace, and then we're gonna search for, let's just first of all disable power, and this time we just don't need voltage. Don't disable the analog one, otherwise all the options will be gone. So because all the voltage values are all analog, so of course you also know that. So this is not a logic level circuit, so this is an analog circuit. So all these voltage values and current values are in analog. So otherwise if you're just gonna click on uncheck analog, so everything is gonna disappear. So what we want is the voltage, is the current across the diode. So we're gonna click on ID1. So this is the option that we're gonna click on. Over here you can see the trace expression has changed to ID1, and we're gonna click on OK. And over here you can see our beautiful characteristics curve of our diode, that is the 1N4007 diode. So we have just obtained the characteristics of the diode. So this is all that you have to perform, and this is the main circuit that we use for the viewers who are just skipping the video and watching it. So again, thank you for watching my video, guys. I hope you liked it, and this was just a really quick video. I had no intent of making the video, and I'm just like sitting up all night long just making this video. So really sorry for the shitty video quality and audio quality. Till then, see ya.